What if I told you that the very technology powering ChatGPT, Google Translate, and even modern image recognition did not exist before 2017? And that one breakthrough, just 8 years ago, took AI from struggling with complex data to understanding context like never before. Today, we are diving deep into transformers. No, not the robots in disguise, but the architecture that changed AI forever. ChatGPT is Chat Generative Pre-trained Transformer. We will talk about that kind of transformer. To understand why transformers are revolutionary, let's take a quick journey through the evolution of AI. We started with neural networks, simple connected layers of artificial neurons passing information forward. These could recognize patterns, like telling whether a digit in an image is a 3 or an 8. Then came deep learning, stacking many layers to capture more complex patterns. This led to breakthroughs in image recognition, speech to text, and more. And within deep learning, we had different architectures for different jobs, like CNNs, convolutional neural networks. They excel at images by scanning them like a moving window. Think of it as looking through a magnifying glass, one patch at a time, to spot edges and shapes. RNNs, the recurrent neural networks, those process sequences step by step, remembering past steps. Imagine reading a book one word at a time and keeping track of the storyline. And LSTMs, long short term memory networks. They improved RNNs by remembering important things for longer, like a reader who keeps notes in the margin of the book so they don't lose the plot. But all of these had a big problem. Older models like RNNs and LSTMs process information one step at a time, word by word, frame by frame. This means that they struggle with long sequences because important details get lost along the way. Imagine you are reading a 10-page mystery novel, but you can only remember the last sentence you read. By the time you reach the final page, you have forgotten who the suspects were. This memory bottleneck meant that they could miss important connections in language, especially when the relevant words or ideas were far apart. The game changer was attention, a mechanism that lets the AI focus on the most important parts of the input, no matter how far apart they are. Picture this. You are in a noisy restaurant with dozens of conversations happening at once. Someone across the rooms says your name. Instantly, you tune in to that voice, ignoring the rest. That's attention, selectively focusing on the most relevant signal. Self attention takes it further. It allows every word in a sentence to look at every other word and decide how much attention to pay to it. Take the sentence, the bank will not approve the loan. The word bank could mean a financial institution or the side of a river. Self attention looks at nearby words like approve and loan and realizes, oh, we are talking about finance here. Under the hood, transformers use something called query, key, and value. Think of it like a library. The query is the book you are looking for in the library. The key is the index card telling you where to find it. And the value is the actual book containing the knowledge. This structure lets the AI find and retrieve the most relevant information, even in huge chunks of text. Here is another killer advantage: speed. RNNs and LSTMs had to process words one after another, like a single chef cooking an entire 10-course meal alone. But transformers? They have a whole team of chefs working at the same time, chopping vegetables, boiling pasta, baking bread, all in parallel. This means massive efficiency gains and the ability to train on huge data sets much faster. In 2017, researchers at Google introduced the paper "Attention is All You Need." It was more than a catchy title. It was a challenge to the AI world. We could drop recurrence entirely, rely solely on attention, and still outperform the best models of the time. Within a couple of years, almost every major natural language model like GPT, BERT, or T5 switched to transformers. Let's make this concrete. Imagine you are building an AI to summarize 10 long customer reviews. An RNN would read them one word at a time, and by the end of a review, it might forget the first sentence entirely. A transformer, on the other hand, reads everything at once, instantly spotting that several reviews mention great teachers or best school, and pulls those ideas into the summary. That's context retention in action. While transformers started with text, they quickly jumped into vision. Vision transformers split an image into small patches, like breaking a photo into puzzle pieces, and treat those pieces as if they were words in a sentence. This lets them capture relationships between parts of an image, something CNNs don't always do well. It's like not just noticing there is a cat ear and cat's tail, but realizing that they belong to the same cat. Transformers are not magic. They are incredibly powerful, but also incredibly hungry, requiring huge amounts of data, computing power, and energy. They can still produce hallucinations, which is confident but wrong answers, and can inherit biases from their training data. And for small, simple tasks, they might be overkill compared to lighter models. Transformers change the game, taking AI from pattern recognition to real contextual understanding. In the next episode, we will go inside a transformer, layer by layer, to see exactly how it works under the hood. Make sure you subscribe so you don't miss it, because once you understand that, you will see why every major AI model today is built on this foundation. Like, comment, share, and subscribe to the channel Kaizen Smarter.